Hello everyone, I am Jagdish Patel, Assistant Professor, Sandeep Foundation, Nasik. The name of subject is Broadband Communication System. This one is Unit 1, Light Wave System Components. And this one is lecture number 2, in which we are going to see key elements of optical fiber system. Specialization in digital communication. Fiber optics cable contains one or several glass or plastic fibers at its core. Or data is transmitted via pulsing light sent from a laser or LED through the central fibers. Surrounding the fiber is a layer of glass or plastic called cladding. Fiber cable variation falls into two categories: single mode and multi-mode. So single mode fiber uses a narrow core less than 10 microns in diameter through which light generated by a laser travels over one path, reflecting very little, allows high bandwidth and long distance without requiring repeaters, costs too much to be considered for use on typical data network. Multi-mode fiber contains a core with a diameter between 50 and 115 microns in diameter. The most common size is 62.5 micron, over which many pulse of light generated by a laser or LED travels at different angles. It is commonly found on cables that connect a router to a switches or a server on a backbone of a network. Fiber optics cable 100 base FX standard. The 100 base FX standard specifies a network capable of 100 Mbps throughput that uses a baseband transmission and a fiber optics cabling. 100B base FX requires multimode fiber containing at least two strands of fiber. 1000 base LX standard. The most common 1 gigabit physical layer standard is used today, can reach 5000 meter and use one repeater between segments. This one is the structure of optical fiber. Here it consists of coating on the outer side. After that it comes a cladding, it comes a core. Means core is on the inner side, over which there is a cover of cladding, over which there is a cover of coating of optical fiber, and combined together form optical fiber. If you observe below, there is one table in which the core is formed by a material and the purpose. The core is formed by material of germanium drop silica glass. Purpose is guiding the light, high index region. That is, next is clad, pure silicon glass or pure silica glass, cover with supporting the lights, that is low index region, over which there is a coating of fiber, that is acrylate coating. Purpose is protecting the glass region. So in this way, by using all this material, the optical fiber cable is formed. Propagation of light through fiber. If you observe, on the input side, the input signal is given from a source of light. It travels, there is a green region or green color region is called as core, above which there is a pink type of violet type of region, that is called as clad, and over which there is a brownish gray type of region, that is called as coating. So the light will travel internal with the help of total internal reflection inside the core only, and it will travel in a zigzag manner, and at the other end it will be received by optical detector. It will be detected by a detector, and after processing the output will be generated. So this one is nothing but the internal structure or traveling or propagation of light in the optical fiber. General, or we can say generic optical fiber system. So here there is a input signal is applied to the optical transmitter. From that the signal is given to communication channel. From that the signal is given to optical receiver, and then the output is generated. So there are different parameters which are used to make the transmission of optical fiber or transmission of light through optical fiber. This one is another detailed structure of optical fiber, or we can say optical fiber transmission system. It consists of power controls, laser drivers, after that frequency synthesizer, decision circuits, clock recovery, multiplexer on the input side through which the input signal is given, after demultiplexer on the output side through which the output signal is taken out. So they combine it together form optical fiber system. This one is another block diagram of optical fiber system. It consists of information source on which the formatting will be implemented. After that, it is given to the modulator. The output of modulator is digital waveforms which is given to transmitter. The output of transmitter is given to the communication channel. After that, the output of communication channel is given to the receiver. From that, it is given to demodulator, and after that, again it is converted into the original format and given to the user. So this section, this one is nothing but it consists of optical fiber which are used to carry the information from transmitter to the receiver. Now there are a number of channels, but optical fiber channel plays a very important role because it suppresses the noise up to a certain extent. It reduces the effect of crosstalk, and due to which it provides a high security of transmission. Benchmark between optical fiber and twisted pair cable. See, I have already told you uh, there is there are a number of cables, but what is the difference between optical fiber and twisted pair cable? The difference is nothing but bandwidth. If you observe, here we are showing with the help of graph. Twisted pair, multi-mode fiber and single mode fiber. So this red color indicates a twisted pair cable bandwidth. After that, this yellow color indicates multi-mode fiber bandwidth, and this green color indicates the single mode fiber bandwidth. So here, single mode fiber having a large bandwidth. Power transmission. Twisted pair cable required less than 0.01% power, whereas multi-mode fiber required 80 to 90% of power, and single mode fiber requires less than 99% fiber. Dispersion. Twisted pair cable is having large number of dispersion, whereas multi-mode is having very less as compared to twisted pair cable, and single mode is having very less dispersion. So due to which the security of transmission is greater in single mode fiber. Important communication systems and technologies. Wide area network, either government regulations or in a public network, we can say we call as a WANs, wide area networks. Main technology is SONET, SDN, ATM, WDM, voice circuit and packets. Non-optical technologies unless encapsulated in SONET and ATM. Standard bodies include ITU, ATM, form relays, IEEE. Metropolitan area region. A man or an covers a North American politician area or a small to medium sized country in Europe or Asia. Main technology is SONET, ATM, gigabyte, 10 gigabyte, Ethernet, DWDM, right? Local area network, main technology is Ethernet. Currently fiber for backbone, access capacity, enhanced power performance. So these are nothing but the different technologies which are used for communication in day-to-day life. Access network, the first or the last network segment between customer premises and a WAN or MAN, owned by a local exchange carrier. Broadband digital technologies, twisted pair cable versus coaxial cable versus fiber, and there are a number of cables. Optical food chain, optical devices. After that, it comes the optical system. After that, it comes the carrier optical network. After that, it comes the service network and applications. If you observe on the right hand side in the blue color, the applications are Amazon, LLBs, GM, and so on which which are operating through a network. Optical communication protocol stack. Here also the same thing has been represented in different manner. It consists of components, devices, fibers, packaging. That is analog layer. In physical layer, it consists of bit single line coding. In above that, there is data link layer, framing, switching, block coding. So these are nothing but the optical communication protocol stack. So here we have seen today what are optical fiber cable, what are the different types of modes of optical fiber, how the internal reflection take place, what is core, what is cladding. After that, we have seen different communication technologies, that is MAN, WAN, LAN, and so on. Thank you.